Okay, it's 12:01. I want to thank everybody for attending today. There was some confusion whether it was this week or next Friday, the 19th. So we'll actually be presenting this again next Friday as a recorded webinar. Good morning, good afternoon, or good evening if you're watching this live or recorded. I'm John Levine of Levine Electronics and Electric. Today's speaker is Mike Bukovich of Tech4. Levine Electronics is a manufacturer's rep that covers Georgia, Alabama, Florida, Tennessee, Mississippi, and Arkansas. We have two divisions, a control division and a power division. Please check out our website at www.l-3.com. Our philosophy is to give back to the industry to make it safer and better for all. We have 3 team members that are officers of IEEE and 3 members that are on the IEEE Pulp and Paper Subcommittee. Michael McClellan, our marketing director, has been running these webinars almost every day to help our customers. You'll find recordings of the ones we've done in the past on our resource page of our website. Right now, I think we got over 36 of them. We're also known as the transformer, arc flash, and protection experts in our territory. If you have questions, you can type it in the question or the chat box. We'll answer these at the end. We also have 4 handouts. Well, actually, there's just 1 handout that of the presentation if you want that. During the presentation, we have some poll questions, and I've also got a little survey at the end. Certificates will go out tomorrow around 5 o'clock. So with that, Mike, I'll turn it over to you.
Well, good afternoon, or for any of you in earlier time zones, good morning. Again, my name is Mike Bukovich, and it's a privilege, absolute privilege, to be with you here today. As we've gone through this pandemic together, we've hosted a number of webinars here already with L3. And I want to point out that we're here for you. Any questions that you have either during the presentation or after the presentation, be sure to forward those to us, and we'll be sure to get you a prompt reply. In addition, the presentation today does qualify for a professional development hour certificate from Tech4. If you would like one of those certificates emailed to you by Mark Hetland, our sales and marketing director at Tech4. Let your L3 representative know, and we'll be sure to take care of that for you promptly at the conclusion of the webinar. What I was asked to present on today, and by the way, this is a brand new presentation for me. I've never given it before. Full disclosure, I completed it at about 2 a.m. my time today after working on it for several days. So open to all feedback on this as well. Michael McClellan asked me to give a presentation on that we had titled New Solutions with Medium Voltage Switchgear. And the focus is in 4 areas. The first is savings, both cost savings as well as space savings, and space savings frequently in many cases equate to cost savings if you're building a new electrical room as well. Improvements in electrical safety in metal enclosed switchgear. Improvements, and we do that primarily through insulated bus and arc flash to mitigate shock hazards, and arc flash mitigation through active arc quenching and arc flash relays to mitigate arc flash risk. We improve maintainability. When I say improve maintainability, it's not a minor improvement. The recommendations for the circuit breakers I'm showing you here under quote unquote normal condition applications is once every 10 years. So that's an order of magnitude of 3 times less than the standard factory mutual or NFPA 70B recommendations for medium voltage circuit breakers, as well as reliability. One of the breakers I'm going to show you today is rated for 10,000 mechanical operations, and the other I'm going to show you today is rated for, hold on to your seats here, 30,000 full load brake operations. Absolutely incredible, the advances in technology and performance with respect to safety, maintainability, and reliability. So without further ado, we will launch into the presentation. So the question is, why should I, consider hybrid metal enclosed switchgear, such as I'm going to present to you, instead of metal clad? And I want to be absolutely clear. We're not here to replace metal clad switchgear. Right? But we do believe that there are many applications, approximately 50% in the marketplace today, according to market research data that we've seen, that would benefit from the type of hybrid switchgear I'm going to show you today. And what I mean by hybrid is it's built to, I want to be clear, this is built to a metal enclosed standard. So it is metal enclosed switchgear, but this switchgear contains elements, right, of metal clad functionality, such as the option for draw out circuit breakers, compartmentalization, metal clad style, bus ferrules, and other features that you would normally only find in a metal clad environment. And these applications for this hybrid gear, I want to be clear, are limited to 1200 amps. And that's the most severe limitation, I would say. So everything I'm presenting today, the switches I'm presenting, the integrated grounding switches are only rated up to 1200 amps, 25 kA. And although 50% of the applications are only up through 15 kV, these solutions I'm presenting to you today, we also offer now in both 27 kV class and 34.5 kV class switchgear as well. The advantages that we pose here, of course, is that we are with circuit breaker technology. We can support secondary virtual mains. We can support improved coordination and ultimately improved maintainability and safety. We're going to discuss footprint. The switchgear I'm going to show you today, and I have some footprint examples I've actually drawn, are substantially smaller than what you're used to with metal clad switchgear. So if real estate is an issue, this should certainly be a consideration. In terms of safety, numerous advances in safety. Arc resistant construction for the disconnect switch itself. The disconnect switch, as you'll see, is a Schneider Electric component. There is no arc rated PPE required for that switching operation, even when standing right in front of the switch. It's an arc-rated enclosure. The third item is integrated grounding. So we eliminate both the risk and time and effort involved in the exposed energized task of grounding, and the grounding operation also becomes a no PPE operation with this type of equipment. It is available electrically operated, and it is similar to metal clad. It is a very compartmentalized solution compared to what you would normally have been used to in metal enclosed type construction. And then finally, after delivering all these benefits, it's certainly a lower price and a dramatically lower maintenance than what you would experience with metal clad style construction. So here's a picture of a typical configuration that I'm presenting to you today, which involves both an isolation switch, okay, with integrated grounding over a circuit breaker. Schneider Electric, for example, once had a product like this called HVLCB. They discontinued that product. And we not only made an effort to continue manufacturing a product just like that, but also added improvements to it, such as draw out circuit breakers, in addition to a fixed mount circuit breaker construction. So again, available in 600, 800, and 1200 amp configurations up to 25 kA. I list the 4 and the 5 kV and 15 kV BIL classes there. All of the dimensions that you see here are, and that I built my presentation graphically around the 5 and 15 kV offering. But again, we do offer a 27 kV and a 34.5 kV offering in this configuration, but it is physically larger than the graphics I chose for my presentation. It meets IEEE C37.20.3, and with the addition of the optional arc quencher module in this gear, we can create an IEEE C37.20.7 solution, totally arc resistant solution as well. So in terms of the, what the hybrid switch, when we say hybrid switchgear, the switch is not available fixed mount. So once you include that isolation switch, you can no longer meet the metal clad standard, but you can get most of the functionality. And when I mean most, again, is limited again to that 1200 amp, 25 kA rating. And you can see from the diagram here, this is a 3-position switch: open, closed, and grounded. And I'll show you later as well that there are viewing windows, arc-rated viewing windows for visible confirmation of blade disconnect or connect to the phases, and visible confirmation of ground switch disconnect without an exposed energized access. Okay, so this is this number 2 here. You see, this is the sealed isolation and grounding switch. This type of design, again, similar to metal clad in many respects here, can include potential transformers, both line and load side current transformers, a high performance, meaning high performance, a much smaller footprint, much lower maintenance, rated for greater mechanical and electrical operations in the circuit breaker. So completely different technology, improved technology in the circuit breakers. This can be designed for both rear access and with no rear access, with incoming and outgoing line termination compartments. So a lot of flexibility in terms of the design. The switch itself that we have grown to love over time is the Schneider Electric LBS kit, load break switch kit. Some people call this the Schneider Electric HVLCC because the same switch is used in Schneider Electric fusible switchgear designated HVLCC. You can see, if you look here at the switch, these two brown, they look gray here, circles, those are the viewing ports from the front of the switchgear, where you can look inside the gear, and it does require a flashlight to do so, and meet the NFPA 70E Article 120.5 requirement for visible confirmation of blade disconnect, as well as visible confirmation of grounding. It is an SF6 switch. It is a very low pressure switch, approximately 6 PSI. There's over 1 million units of these installed in the world. This is a very mature product. It's been around since the 1990s. And there's never been a single leak just because the pressure is so low inside. And the switch is available again in 5, 15, and 27 and 34.5 kV flavors. In terms of space savings, front accessibility, something you don't, this is something you don't get obviously with metal-clad switchgear. This allows for installation against a wall. It eliminates the National Electric Code requirement governing rear aisle space. So in terms of real estate savings, not only are we saving in the width dimension, but the fact that we can install against a wall saves a tremendous amount of space inside the electrical room. So we're reducing the square footage necessary for installation. And of course, you know, when you optimize the square footage use, you're saving your customer money as well. And this equipment can be close coupled to medium voltage starters. It used as a primary and transformers and unit substation, or integrated as part of a lineup with a common horizontal bus. This shows a calculation of the space savings with using metal-clad switchgear and the total square foot. This is just something that we sketched up. And if we look at the comparable now, oops, sorry. If we look at the comparable now with the hybrid design I'm showing you, you can see the difference: 144 square feet versus 188 square feet in terms of the space requirement. So considerable space savings inside the electrical room. This hybrid metal-enclosed switchgear, highly efficient itself in terms of its the footprint itself is 35% less than you would typically find in a metal-clad switchgear design, and has a number of integrated safety features for increased personnel protection. So in order, we have an option for active arc quenching. I'll cover that. This is not an arc quenching presentation, but the bottom line is, but via installation of the arc quencher device and the arc quencher system, we guarantee both in the switchgear and in downstream assets that are protected by the light sensor network, we guarantee less than 1.2 calories per centimeter squared at the IEEE 1584 working distance, which for this equipment would be 36 inches. And then the third item is integrated grounding. And do not underestimate the benefits of integrated grounding. This is something that typically when I show it on paper like this, people tend to ignore it or pass over it or see it as a minor benefit. But once the equipment actually arrives in the plant, and the maintenance people, who are used to, when it's time to ground, opening up the disconnect source, either the load break switch or a circuit breaker, getting into category 4 PPE, getting into the appropriate voltage rated PPE, opening up the equipment, verifying absence of voltage, and then using hot sticks, to attach. Well, they attach the ground cable with their hand to ground, but then they use a hot stick to attach to each of the 3 phases. And I have to be honest with you, when Europeans come over here and see Americans on new equipment going through that process, which A, is considered an exposed energized task by NFPA 70E, and B, it's very hot, difficult, and time consuming. When they see us do that, they think we're barbarians, because for the last 20 plus years, integrated grounding has been a requirement in similar new equipment in the IEC world, which governs almost every country on our planet other than Canada and the United States. We shipped a very similar lineup to this to the largest gray iron foundry in the United States as a temporary solution. It was only meant to be temporary for furnace disconnects while the plant was redoing its medium voltage infrastructure. And as part of that plan, these switches are going to be redeployed to be the primary of unit substations. Yet the maintenance people so fell in love with integrated grounding that when the time came to move it, they said, "You're not taking these switches from us. These are ours. You can buy another 10 switches for the primaries of your unit." So that's how valuable they found the integrated grounding feature to be. And once you walk up to the switch, you open it, verify visible confirmation of blade disconnect, move the tool to a separate port on the front of the mechanism and ground it, and then verify through the front port it's grounded. Apply your lock, so you've grounded and locked out and tagged out, and it's taken you 10 seconds and required no personal protective equipment, and it's perfectly safe. Once you've experienced that versus the traditional method, you would never go back to the old school way of grounding. There is reduced cost associated with this construction. So it just hard cost savings compared to metal clad. And as previously mentioned, we offer both front and rear accessible designs in this equipment. In terms of maintainability, it is available with either fixed or draw out breakers. If you do choose a fixed mount breaker, I can tell you I have done it myself. I've removed a breaker and put in a replacement breaker in less than 15 minutes. So certainly fixed mount is an option, even in process environments. Because again, I have the isolation switch above with insulated bus, compartmentalized, where I've isolated, locked out, tagged out, and have load side grounding with that switch. It's a switch over breaker design. There's two different breakers that we do offer for this design currently in the 5 and 15 kV categories, which again is the emphasis of my presentation today. And that is the Schneider Electric Evolus, the French would say Evolus, for that breaker, and the Tavrida arc flash breaker, which is pictured above it. And both of these breakers are available in either fixed mount or draw out applications, and we have installed base references for both of those. In terms of the construction of this hybrid metal enclosed switchgear, you can see that similar to metal clad, again, borrowing some of those design features, it's a highly compartmentalized design. Typically in our design, we have the arc quencher located in the top cubicle. The breaker, and this is strictly a one high design, so two high is not available in this design. And the targeted maintenance for the circuit breakers here is 10 years for either the Evolus or the Tavrida circuit breaker. The switch, the isolation switch, is electrically interlocked with that circuit breaker. So I want to be clear, that is a load break switch. You can absolutely load break with it. However, in terms of the control features, it's desirable from a control point of view because of the number of operations it's rated for, to have the circuit breaker interrupt the load. So the circuit breaker is electrically interlocked. So if you try to open the switch, okay, well energized, the breaker will automatically open at that. That aux contact from the isolation switch is tied into the breaker's open circuit. Cable connections, top or bottom. We also do side termination when there is insufficient space, and we have no rear access. This is a picture of the Schneider Electric Evolus circuit breaker, both a rear view and a front view of that breaker. It's one of the most popular medium voltage breakers in the world, with over 1 million units sold. It's rated for 10,000 mechanical operations. 3-cycle interruption. And again, from a width point of view, this is able to be installed in switchgear up through 15 kV, which is only 26 inches wide. And moreover, we're going to go to the next slide here. It shares its operating mechanism and accessories like the shunt trip accessory with the Schneider Electric low voltage master pack circuit breaker line. So it's if you look at the Evolus breaker, it looks like a big brother or the larger version of the Schneider Electric master pack low voltage circuit breaker. And I could be wrong here, okay, and I'd love to be corrected, but I believe it's the only circuit breaker line currently available that shares a common mechanism as well as accessories between the low voltage version of the breaker and the medium voltage version of the breaker, which is the Evolus vacuum breaker you see here. We offer, of course, a wide range of current transformers, both standard and high accuracy, available in the design. This circuit breaker is, I'll be real up front here. This is my current favorite circuit breaker. We have ourselves, or L3, we have no commercial connection to Tavrita. We're not representatives for Tavrita, but we are huge proselytizers of electrical safety, maintainability, and reliability. And this breaker this Tavrita circuit breaker has been taking the market by storm because it is a game changer. The breaker comes with a 5-year warranty, and it is rated for 30,000 operations at full load, which is incredible. But the most compelling aspect of this breaker, besides the fact on top of all of that, it's smaller and lighter than competitive breakers in the category, is the 5 and 15 kV version has a 12 millisecond opening time. The 27 kV and 34.5 kV version has a 26 millisecond opening time. But 12 millisecond opening time is 4 times faster than even what is considered a fast 3-cycle breaker like the Evolus I just showed you. So this not only mitigates arc flash risk, but dramatically reduces system stress. So more mechanical operations, more electrical operations, less maintenance, longer warranty, and dramatically reduced arc flash incident energy are the hallmarks of this circuit breaker. The low voltage compartment, I have just some diagrams here with the left, front, and right sides of so there's a separate compartmentalized low voltage compartment. If the arc quencher option is utilized, this is where we put our arc quencher controls as well. Again, this is not an arc quencher presentation. There's a separate L3 webinar on active arc quenching, but that option to deliver a IEEE C37.20.7 solution without mechanical venting, without plenums, is available in this equipment. This shows a picture of the PT and the CT transformer compartment. It is available either fixed mount or on a removable truck, as shown. This just shows a typical example here of a bottom cable compartment. And I'm not going to kid you here. You can look on the right and the left side. One of the challenges if you go with compact gear, which is 26 inches wide, is the amount of installation space available to do the stress counts and make the terminations is going to be tighter, of course, than what you would experience on 30 in a 26-inch wide environment, that obviously compared to what you'd have a 38-inch wide environment. But in all cases, we haven't had it, and we've installed a lot of this equipment already. Haven't had any complaints from any of the electricians who've installed this equipment. People are getting used to the fact that equipment which is smaller, more compact, is a tighter fit during the installation process, but it requires so much less maintenance and is so much safer that and cost less, that those advantages are compelling. Even when you got to take the pluses and the minuses whenever you go to a compact design with respect to installation difficulty. And as previously noted, we have both front and rear accessible designs in this equipment. So we could do a side termination compartment even with a draw out switchgear in this design, and put the equipment against a wall and save that rear aisle space. This shows a detailed view of the main breaker. This particular one you're looking at here is for the fixed mount design, not the draw out design. This type of hybrid metal enclosed switchgear is absolutely perfect. It's the ideal equipment to serve as the transformer primary disconnect and create a secondary virtual main. And the economics of switchgear has really changed over the past 5 years. Low voltage breakers continue to get more expensive, but medium voltage breakers, due to the dramatically decreased size and new materials used in MV breakers, have actually gone down in price. So by eliminating the secondary physical main, and we have a completely separate presentation L3 does on secondary virtual mains, so it's not my purpose in this presentation to recap all the advantages of secondary virtual mains. But the bottom line is this hybrid switchgear is the right solution on the primary side of the transformer. And for the amount of money you save eliminating the secondary physical main, both the cost and the space savings, it will pay for it's enough money to pay for upgrading from a standard air brake fusible switch to this type of solution. The economics of it are almost identical. In fact, on a recent job that Tech4 won, one of Mark Hetland's jobs at Tech4 that we worked on, we were required to provide a price for a traditional unit substation, which had an air brake switch and with fuses on the primary of a transformer substation and a physical secondary main. And then we were also asked to deliver a safety plus solution, which eliminated the secondary main and put one of these hybrid switchgear solutions on the primary. And the hybrid solution in the end cost $1,000 less than the traditional solution. So not only did you get the improved maintainability, the much greater, much less, dramatically reduced footprint, dramatically improved safety features, but on top of all that, the total solution costs less. On top of that, arc quenchers and of course active arc quencher protective relays are available in these hybrid configurations. And again, to be clear, if you or your customer is satisfied with 8 calories per centimeter squared or 4 calories per centimeter squared, you do not need to implement an arc quencher to achieve that. We can typically achieve that with zone selective interlocking and differential relaying in this equipment. But if you're in a critical power environment where you want to ensure the survivability of the asset itself and the downstream assets themselves that are protected by the light sensor network. So if you're in a critical power environment, arc quenchers and active arc quenching, of course, we believe this represents the future of electrical system safety and reliability both in the United States and globally. In terms of the applications, we can put it on a transformer primary with rear access. We can have a front access transformer primary and a duplex transformer primary, as shown in the attached diagrams. We support ring networks. So if you look up above here, this would be, in this case, we had, masterclad or metal-clad switchgear. Because the assumption would be those circuit breakers up there might be larger than 1200 amps, and we're limited to 1200 amps with our hybrid solution. But then you can see how this could be configured in a ring network to provide an additional level of redundancy and reliability in a critical power environment. So typical classical ring network configuration. This equipment lends itself very well to that type of configuration. So in terms of the benefit summary, reliability, there's no breaker in the world that could come close to 30,000 full load break operations with that Tavrita breaker. Maintainability, either the Tavrita or the Evolus in a normal installation environment is recommended once every 10 years compared to once every 3 years for most traditional circuit breakers. Safety, there's the integrated ground, which I mentioned is a very compelling feature, and the ability to deliver C37.20.7 arc resistant performance with the active AQ2000 arc quencher is compelling. And remember, anywhere that light sensor network is extended to downstream, so you have motor control centers and substations and variable frequency drives, whatever you have that is fed from this equipment, those same arc resistant benefits can be extended to those assets. And of course, we cover that in detail in our separate arc quencher presentation. And cost savings, it's typically, and this varies by configuration, of course, but it's typically 30 to 40% less when you hybrid switchgear as compared to traditional metal-clad switchgear. In terms of support resources from L3, any questions you have about this equipment, the LBS kit, that disconnect switch catalog, we have switchgear power systems brochures detailing the sizes and dimensions and specifications, including VIL ratings, of course, and interrupting ratings on all of this equipment. We have the arc quencher brochures and manuals, which are associated with the separate L3 webinar presentation on the subject, as well as arc quencher system sample drawings. So again, if you're interested in that new exciting arc quencher system technology, we have a host of collateral material we can use to support your design efforts. If you're interested in that exciting Tavrita circuit breaker, we have both brochures and manuals on the Tavrita circuit breaker. We have sample drawings in AutoCAD format that we can sanitize from similar projects and send you. So if you're a consulting engineer or you're just trying to work up an initial design, you don't have to start from ground zero. We're here to support you in your engineering design efforts, reduce the amount of, not only reduce the cost of the switchgear itself, but reduce the amount of time it takes to design and implement this type of solution. And we also have a one-page document you can request from your L3 representative. We call it the Arc Flash Mitigation Toolbox. This lists every approved NEC 240.87 and NFPA 70E Annex O, all in the same chart. And we list every approved arc flash mitigation method, how it accomplishes the mechanism by which it achieves arc flash mitigation, okay, the approximate clearing time associated with that arc flash mitigation method, and then any advantages or disadvantages associated with that solution are summarized all in one nice document. So for anyone who's doing design with with it taking arc flash and electrical safety into account. It's a great document to have as a reference design tool. Again, all of this available from your L3 sales engineer. And other than that, I'm done for today. I'm going to see if there's any questions that have popped up here. Again, it's been a privilege to spend this time with you this afternoon. Anything we can do to help you with your switchgear designs to make them safer, more reliable, and more maintainable, and save you money at the same time, we're here to support those efforts. So thank you again. Be safe during the pandemic, and we'll see if we have any questions today.
That was a great job. Everybody, I've just put up a real simple poll question. If you take a second and fill that out, I'd appreciate it. If you'd like someone to contact you in regards to this presentation or an application you may have. Also, when we close it, you'll get 2 quick survey questions that we'd appreciate you answering. Mike, I do not see any questions, which means you did such a good job.
or everyone's eating lunch right now, John. I appreciate the kind words, my friend. Again, anything we can do to support you and your customers, and this effort, we work in an industry in terms of electrical power, which tends to have adopted technology at a slower pace, quite frankly, than our counterparts in the automation and robotics sides of our industry. And because we live in the most litigious society on earth, safety has become far more compelling, and there's so many more critical power environments nowadays too. So I think this is a very relevant topic in terms of how to improve our electrical system designs for safety, reliability, maintainability. So again, thank you to everyone. And please, if you need anything from me, you can feel free to contact me directly. All my contact information showing here at any time. And your L3 sales engineer is always available to assist you face-to-face as well. So have a great afternoon, have a great weekend, and we'll look forward to the next L3 webinar.
Thanks, Mike. Everybody be careful out there. Bye-bye.